Good morning, how are you, my learners? It's Murad Sultan is ready again with you. Okay, so at least now you can find it out or find the perimeter and area of polygons and especially for compound shapes. Okay, either the area or the perimeter, and let's say you can investigate by drawing triangles or to see the number how many ways can you split these compound shapes. Okay, now we try to move in see new lecture that deals with, let's say, area of regular shapes. Okay, so we told that students use their knowledge of counting squares to estimate the area of shapes that are not rectilinear. They use their knowledge of fractions to estimate how much of a square is covered and combine different part covered squares to give an overall approximate area. Student needs to physically annotate to avoid repetition when counting the squares. Okay, how many whole squares can you see? For example, here my learners, we have we divide this into 9 squares. Okay, so 1, 2, 3, 9. Okay, how many whole squares can you see, my learners? For example, one student can count like that: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, another student can let's say another student can count like that. Okay, for example, this consists of 14 squares. Okay, he will count like that. Look, one square, 2 square, 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, 9 square, and so on. For example, he told that it's 13, no false. Okay, this is 12, okay, 13, 14, 15, 16. Or, okay, so means that how many whole squares can you see in this pattern? You should count them. How many parts squares can you see? Then, can you find any part square that you could be put together to make a full square? Then what will we do with the parts? What does approximate mean? Means what approximate, my learners? Means that it's close to the answer. For example, 3.5 multiplied by 2 is 7. And if you like to estimate this, you will tell that 4 multiplied by 2 is 8. So 8 is near to the exact value. 3.5 by 2 is the exact value, okay? Or the correct answer. But this one by estimation, okay? Then, or you can also do like that. 3 multiplied by 2 is 6. So the correct answer should be lies between 6 and 8. Mean the area should be is greater than 6 and less than 8. Means that the area as a real or exact value will be 7. Okay. Estimate the area of the pond. Ron's answers is 4 whole squares and 11 parts. Okay, 11 parts. Let's do it. Okay, I think that it's not clear. Okay, no problem. So, Ron's answers is 4 whole squares and 11 parts. Let's first count the squares. This is square number 1. Square number 1. You see? Square number 2. Square number 3. And and square number 4. Okay, these are seems like to be a whole square that everyone can see. Okay, Ron's answer is 4 square and 11 parts. Look, this is number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Correct. Okay? Then, what can we do with the parts to find an approximate answer? Means that if all of the squares are 1 centimeter in length, which shape has the greatest area? So let's do this one for example. This one, my learners, you can see that this one, this square, okay, is less than a half square. So negligate it. Don't put it into consideration. For example, this one, my learners, is this one is more than a half a square, but less than 1 square. I will consider. Then this one also is like that. It's less than 1 square. I will consider because it's more than half. This one, ignore this one. This one, ignore it. This one, I will accept it. This one, okay, I will accept it. This one is more than half, my learners. More than half. I will accept it. So how many squares in fact? 1, 2, 3, 4, 5, 6, 7, 8. So this has an area of 8 centimeters squared approximately. Approximately, it's about 8 centimeters squared. Okay? The next question, if all of the squares are 1 centimeter in length, which shape has the greatest area? Okay? This is the first shape, the gray. This is the green, and this is the orange or red. Is the red shape, okay? Is the red shape the greatest because it fills more squares? You can see that here. For example, look at this square. Okay, we will use another. This is square. We thought that we can consider 1 whole square if it is more than half. So this one, it will fit 1 square. We will accept it. Okay, approximately we consider as 1 whole square. Okay, the next one, my learners, for the second square, look, like that. This is the second square. But the red one is like that, my learners. So it fits more than a half. I will consider it. Look, this one also. You see the third square. But the one that I will put in consideration is the red one. Is more than half. So I will consider it. This is also, my learners, the fourth. The fourth square will be like that. You see the red one, the part that is colored red, is more than half. I will consider it. Okay, and so on. So by counting these squares, okay, you can approximately at least distinguish between those shapes that have the greatest area. Okay, so got that. In the red shape, the greatest because it fills more squares. Okay, what is the same about each image? What is the difference about this one? If we can say that. This one, okay. This is 1, 2, 3, 4. Okay, this one can, let's say, fill more squares, but this one is the shortest shape, let's say the least shape that can fill more squares. Okay, so this is number 1, my learners, in area terms. This is number 2, and this is number 3. Number 3 means smallest. This is largest, then comes this, then that. Okay, each square is about what? Okay, what is the same about each image? Okay, different about the images. So here we thought that I will count them. Okay, no problem. So this is 2, 3, 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11 squares. 11, so this one is, okay, let's set this, y square. So this one modernus like that, approximately is half, I will consider also, so this is 12 centimeters squared. Then the next one, this is modernus is, okay, is 1, okay, 1, 2, this is 3, 4, 4, this is I will consider 5, this is now, this is 6, this is 7, okay, this is 8, this is 9, okay, this is 10, this is 11, so this is 11 centimeters square, approximately modernus. And this one, we have, okay, we have 1, okay, we told that. See also like that. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So okay, x square is approximately is about 11 to 12 centimeters square, approximately. Okay. Then look at this shape. Here we try to find the area of this one. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is less than half. I will never accept it. So 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24. This is more than half. 24, 25, 26, 27, 28, 29, 30, 31, 32, 34, 35, 36, 37, sorry, 38, 39, 40, 41, 42, 43, 44, 44, 40, 41, 42, 45, 46, 47, 48. This is modern, approximately 48 centimeters square. Okay? Now, okay, shapes with the same area. Okay? A student will find and draw rectilinear shapes that have the same area. Okay? Children also, a student use their knowledge of factors to draw rectangles with different area. Okay? Meaning that, for example, if I'm again telling you try to draw 3 rectangles with the same area of, for example, draw 3 different rectangles that have the same area of, for example, 6. Okay? 6 centimeter or meter square. We will think of the factors of 6. 1 multiplied by 6 is 6. 2 multiplied by 3 is 6. Okay? And for example, okay, I will tell you, try to at least draw two different rectangles that have the same area but different lengths. So this is, for example, making that length, width. This is 2, this is 3. Then the next is 1, 6. All of them have the same area, which is 6 centimeters squared. Okay, clear all.